Our final lesson of this chapter looks at fractional equations. This is different than a fractional coefficient. The equation is an equation where the variable is actually in the denominator. When you're solving fractional equations, there are what's called extraneous roots. This is a value that you're going to get as an answer, but when you plug it back into the original, it doesn't work. So when you're solving these, the most important thing is that you have to check, no matter what. Most of you will get points off of your test for not doing this, but anytime you get the solutions, you have to check them to see which ones are extraneous. To solve these, you're going to do just what you've been doing. You're going to multiply both sides of the equation by the least common multiple of all the denominators. That way you're going to clear out the denominators from the equation. So let's take a look at the first example. You all know how to find the least common multiple of denominators. One thing that you should recognize is that this denominator is not quite what we want it to be so that it would match up with the other two. So we can actually adjust this a little bit so that it looks the way we need it to look. Remember that you can always factor a -1 out of something. And when you do that, we've got this z plus 3, and I can make that -1 times z minus 3. The rest of the equation would stay the same. And then finally, anytime you've got something in the denominator, you really can move it into the numerator. So I'm going to erase the -1 from the denominator here because it could also be in the numerator. So now if I look at the least common multiples of all the denominators, this is the least common multiple. So I will multiply every single fraction by z plus 3 times z minus 3. And what happens? The whole thing cancels here. The z minus 3 cancels there. The z plus 3 cancels here. So I'm going to distribute this -1 to the numerator first. Then I will FOIL the rest of it. So I end up with -z minus 3 times z plus 3 plus 11z plus 3 is equal to 1 minus 5z times z minus 3. So as I start to distribute this, I get -z squared minus 3z minus 3z, so that's minus 6z minus 9 plus 11z plus 3 is equal to, that would be z minus 3, right? So z minus 3 minus 5z squared and then plus 15z. Then we can start to combine like terms. And then we start to simplify. This would be 5z minus 16z, so that will be minus 11z. Minus 3 is equal to 0. And then we factor. That's 4z squared minus 12z plus 1z, negative 11z minus 3. So I know that z is either negative 1/4 or positive 3. We are not done. Now we need to check. Oops, I didn't want z there, I actually wanted 3. One thing that you'll notice, denominator is 0, denominator is 0, 3 is an extraneous root. We will also need to check negative 1/4. When I simplify, I see that this is equal to 9/11 on the left-hand side, 9/11 on the right-hand side, and those check. So, because 3 is excluded from the domain, which we could have very easily seen, 3 minus 3 is 0, 3 is not a root. We'll try the next one. It's quite a bit easier to see. The least common denominator is x squared minus 4. So that's x plus 2 times x minus 2. I have to multiply that 1 times x plus 2 times x minus 2. And then I have to multiply this. X plus 2 times x minus 2. The whole denominator here cancels. You're left with 10. 1 times all of that will give you x plus 2 times x minus 2. And then minus, we can see that the x plus 2's cancel. 1 times x minus 2 would be x minus 2. And I can then factor. X squared minus 4x plus 3x, that's negative 1 minus 12. So now I check. That gives me 5/6. That gives me 5/6, which checks. Then we try the negative 3. The left side I get 2, the right side I get 2, and that checks. Please understand that I want to see this check. I don't need to see every teeny little step in between. but I need to see that you've done this. I need to see that it works. I will know if you put things in that don't work and then just stick a check mark next to it and say, oh yeah, I did it. You must do this part of it. Now we're seeing a distance problem. You guys saw some of these already. For all distance problems, you need to remember distance is equal to your rate or your speed times time. So we're driving the first half of a trip at 36 miles an hour. We need to finish the trip at something so that we've averaged 45 miles an hour for the whole trip. The hint here is set the trip distance equal to a value that's easy to work with. So what I do is I actually set up a chart for this. So I say distance is equal to rate times time. So we have a first half, and we have a second half, and we have the whole trip. So her distance, we don't know what the distance is. I'm going to set it equal to 50. So her whole trip is 100. Her rate, we know, is 36. Her rate for the second half, we don't know. But for the whole trip, the rate needs to be 45. So, if distance is equal to rate times time, if I want to solve for time, I divide by rate on both sides. So that means my time is 50/36, 50 over x, and 100 over 45. So now I simply add 50 over 36 plus 50 over x is equal to 100 over 45. My least common denominator is 180x. So 36 cancels here and becomes a 5. So that's 250x. The x's cancel. 50 times 180 is 9,000. And then the 45 cancels, leaves us with 4, so 400x. And then we simply solve. So I have 9,000 is equal to 150x. Solve for x. So she should drive miles per hour for the remainder of the trip. Alright, so I've got one more distance problem. Again, distance is equal to rate times time. We're changing planes to ones that fly 100 kilometers per hour faster. The time of the trip for this given distance is reduced by 30 minutes. Notice we're in hours and minutes, so this has to be half an hour. We're going to find the speed of the new plane. So I have my formula here. Distance is rate times time. So I've got old planes and new planes. My distance is 2,800. My rate is something, and my new rate is that plus 100. My time, remember, we write time in terms of the other two variables. So that's 2,800 over r, and 2,800 over r plus 100. My new time is half an hour faster. So what I want to do is say, if I take the old time minus the new time, my answer will be 1/2. My common denominator is 2r times r plus 100. So this r cancels, and I have 2r plus 200, right? So this cancels out, so 2r plus 200 times 2800 minus the r plus 100 will cancel, so that leaves me with 2r times 2800, so that's minus 5600 r, and then the 2 here cancels with this one here, so I just have r times r plus 100. When I simplify, these cancel, and I'll do the next thing in 2 steps in one. I'm going to move this over, and I will rewrite it all with my quadratic on the left. And so then I factor. Well, we know it can't be negative 800, so r is 700, which means my new planes go 800 kilometers per hour. This last problem looks at splitting up money values based on number of people attending. So we've got members of a ski club contributing to some kind of trip that costs a total of $1,800 no matter how many people are going. 6 people can't go, so their money had to be refunded, and then everybody else had to pay an additional $10 to raise the full amount. So how many people went on the trip? The way we're going to start this is we're going to think about the total cost is equal to the number of people times the amount each person pays. So if I set up a chart for this, that's exactly what I'm going to write in. So there's the total cost. Here's my number of people. And there's my amount per person. So I have my original group, and then I have my new group. The total cost of the trip is $1,800 regardless of how many people go. The number of people that I have in my original group is something, and in my new group it's 6 less. So the amount per person be 1,800 divided by x, and 1,800 divided by x minus 6. Now, remember that each one of these is the amount one person pays. So if I take the amount that I'm paying minus what I was paying before, the difference is $10, right? So I'm paying $10 more here than I was here. I'll set that up in an equation. 1,800 over x minus 6, that's my new amount, minus my old amount, which is 1,800 over x, it'll equal 10. My least common denominator is x times x minus 6, x times x minus 6. So on this first fraction, the x minus 6 will be eliminated, and I will be left with 1,800x. On the second fraction, the x here will be eliminated. So I will be left with 1,800 times x minus 6. And then the thing that every one of you seems to forget at one point in time or another, you also have to multiply this by the right-hand side of the equal sign. So that gives me 10x times x minus 6. As I expand all of this out, You see that these two 1800x's cancel, and then from here I am going to rearrange everything in a way that's easy to see, and I'm going to move way up to the top of the screen here. So that's 10x squared minus 60x minus 10,800 is equal to 0. I can factor a 10 out of each term. And then I can factor the polynomial. So this means that x is either equal to negative 30 or positive 36. Well, obviously we can't have a negative number of members. That means that the original amount was 36. When I subtract 6, I now have 30 people going on the trip.